electronegativity. They also have, again, look at these three values: nitrogen 3.0, oxygen 3.4, fluorine 4.0. Again, anything above 2.5 is considered very high electronegativity, so especially above 3. So remember, nonmetals want to do what with their electrons? They want to gain electrons. What's the definition of electronegativity? The ability to gain electrons. So they want to gain electrons, they're going to have a high electronegativity. All right, so we're going to demonstrate this. All right, so if I'm, here's an electron. If somebody wants to gain it really bad, they have a high electronegativity. Come get it. All right, so, or even better, I'll do it for you. They gotta have you. They gotta have you. All right, high electronegativity. You gotta gain that electron real fast. Thank you. All right, so number 5, have high electronegativities because they want to gain electrons. Number 5 is have high electronegativities because they want to gain electrons. Okay, again, if you notice, everything is opposite of metals for nonmetals. Okay, remember, metals are malleable. They can be hammered into sheets, and they can be made into wires. They're ductile. Nonmetals cannot be malleable. They're not be ductile. All right, if you put a hammer to a nonmetal, it'll shatter. It's very brittle. All right, so they're not malleable at all, and they can't be made into wires. They're not ductile. So why don't you put for number 6, not malleable, and have little ductility. Not malleable, and have little ductility. Ductility is D-U-C-T-I-L-I-T-Y. Not malleable and have little ductility. Okay, like I said, metals are good conductors. Non-metals will be poor conductors. Number 7, I want you to put soft, brittle, and poor conductors of heat and electricity. Soft, brittle, and poor conductors of heat and electricity. All right. Then put in parentheses poor thermal conductors and poor electrical conductors. That means poor conductors of heat and electricity. Poor thermal conductors and poor electrical conductors go in parentheses. Okay, now pause the video and answer the questions on pages 6 and 7 related to nonmetals. Okay, question 1. Which is a property of most nonmetallic solids? The best answer there is choice 3, brittleness. All the other 3 choices represent metal properties, metallic. So nonmetallic is brittleness, 3. Number 2, based on electronegativity values, which type of elements tend to have the greatest attraction for electrons in a bond? The greatest attraction for electrons is greatest electronegativities. And where are these elements? NO and F, those are nonmetals to the right of the staircase. So the answer is nonmetals, choice 3. So nonmetals have both high electronegativity and high ionization energies. Number 3, compared to the radius of a chlorine atom, 287, the radius of a chloride ion, 288, is going to be larger because chlorine gains an electron. -1 means you gain electrons, so it's choice 2, larger because chlorine gains electron. Remember, nonmetals now, ion is larger than atom. Okay. Page 7. What are 2 properties of most nonmetals? Again, if you forget, remember your choices are between, we know it can't be good electrical conductivity, it has to be poor electrical conductivity, so it can't be 2 or 4. And then if you forget what type of ionization energy they have, just go find a nonmetal on the right side, like fluorine, look up here. That's a very high ionization energy, so the answer is choice 1. High ionization energy and poor electrical conductivity. Number 5, an element that has both a high ionization energy and a high electronegativity is most likely a choice 2 nonmetal. Again, just look on table S and the periodic table. Number 6, at STP, which element is brittle and not a conductor of electricity? So brittle, non-conductor electricity, look for the one choice that's a nonmetal, look for something on the right side of the staircase, and the only thing on the right side of the staircase there on the periodic table is choice 1, S. Okay, 7. The S-2 ion differs from the S atom in that the S-2 ion has a, okay, so S-2 ion compared to the S0 atom, the answer would be 4. The S-2 ion has a larger radius and more electrons. Right? This, remember, you gain 2 electrons. This has 2 plus 8 plus 8, 18 electrons. This only has 2 plus 8 plus 6, 16 electrons. So it has a larger radius, so there's more electrons. It's choice 4. And number 8, when a fluorine atom becomes an ion, it will, again, fluorine's nonmetal, so when it becomes an ion, it must gain an electron. So it's 2. Gain an electron, and it gets bigger, increase in size. All right, it's a nonmetal, so it's increase in size, choice 2. Okay, number 9, explain in terms of subatomic particles, meaning protons, electrons, and neutrons, why the radius of a chloride ion is larger than the radius of a chlorine atom. So why is the radius of a chloride ion larger than the radius of a chlorine atom? Because chloride ion has more electrons than a chlorine atom. That's why I have to say that. Because the chloride ion has more electrons than the chlorine atom. And finally, number 10, explain in terms of atomic structure why the atomic radius of iodine is greater than the atomic radius of fluorine. Okay, that's a little bit different now. Now you're comparing iodine with fluorine. Iodine's further down, so iodine's going to have a lot more shells than fluorine. Fluorine has 2 shells, 2-7, and fluorine is in period 5 that has 5 shells. So iodine has more shells than fluorine. That's why the radius of iodine is bigger than fluorine. Okay. Now the last thing we're going to do today is a short lesson on metalloids and answer some quick questions. So it should only take another 5 minutes or so. All right, so now come back to the staircase. Here's our famous staircase. Everything to the left of the staircase was what? A metal. Everything to the right of the staircase was what? A non-metal. All right, but now you have something that's right on the staircase, and that's called a metalloid. Those are your metalloids. They're located right on the staircase, and they're sometimes called semi-metals. Semi-metals, they're not totally metal. It means they're partially metal and they're partially non-metal. So they contain properties of both. They have some metallic properties and they have some non-metallic properties. Okay? So those are metalloids. There's only 6 metalloids that you're responsible for. And we're going to get to that in a minute. The first right, number 1, located on the staircase of the periodic table. Located on the staircase of the periodic table goes for number 1. Located on the staircase of the periodic table. Remember, they're not totally metal, they're not totally non-metal. They have some properties of both. So number 2, you're going to write have some properties of both metals and non-metals. Number 2, have some properties of both metals and non-metals. Or you can write have both metallic and non-metallic properties. All right, and the 6 metalloids you need to know. The easiest way to remember it is Bob sits as teacher gets subway. Again, it's Bob sits as teacher gets subway. So B, S-I, A-S, T-E, G-E, S-B. So it goes in order. Bob sits as teacher gets subway. All right, so number 3, I want you to write out the following for number 3. I want you first to write out the names. Boron, silicon, arsenic, tellurium, germanium, and antimony. Then write their symbols underneath them. Boron is B, silicon is Si, As is arsenic, tellurium is Te, germanium is Ge, and antimony is Sb. Okay, then underneath that, for number 3, I want you to write out the saying. Bob sits, underline B for Bob, boron, sits, underline Si for silicon, as, that's arsenic, teacher, Te for tellurium, gets, Ge for germanium, and subway, Sb for antimony. So Bob sits as teacher gets subway, that's the easiest way to memorize your 6 metalloids. Bob sits as teacher gets subway. And those are all located on the staircase. So they're right on the borderline between metals and non-metals. That's why they're called metalloids or semi-metals. All right, so now pause the video and answer the 10 questions on page 8. Okay, question 1. Which electronegativity value is the most probable for a metalloid? Remember, electronegativities go from 0 to 4.0. So metalloids right in the middle between 0 and 4.0. What's half of 4? 2. So most electronegativity values, if you look them up on table S, are near 2.0. Okay. For example, if you look at boron, here's your first metalloid, 2.0. Silicon, 1.9, so very close to 2.0. So the best answer is 2.0, choice 2. Okay, number 2, the atomic number of a semi-metal metalloid in period 4 is, so now you go to period 4. Period 4 is the fourth row on the periodic table. Okay, what are the metalloids in period 4? Ge and As, germanium and arsenic, and the choices are atomic numbers. Which atomic number is there? 32 or 33? I see atomic number 33, choice 3. So that's the atomic number of semi-metal in period 4. Okay, number 3, which element is not a metalloid? So just do process of elimination. Which one is not Bob sits as teacher gets subway? The only answer there is choice 2, lead. Lead is not a metalloid. Number 4, which is an example of a metalloid? Again, they'll use 6 metalloids. The only one that's there is choice 3, silicon. Number 5, which element in period 3 has both metallic and non-metallic properties? Having both non-metallic and metallic properties means metalloid. And period 3, third row, let's go with the third row, the only metalloid in period 3 is silicon. Right, so that's choice 3, Si. Number 6, which list of elements consists of metalloids only? So again, which one has a list of these 6 in it? Choice 4. Choice 4 says Si, Ge, and As. Choice 4. Number 7, which element is a metalloid? Which one's Bob says his teacher gets subway? Choice 3, As. Number 8, which group contains a metalloid? Which group now? Which column contains a metalloid? Choices are group 1, 11, 15, or 18. Group 15 contains 2 metalloids, As and Sb, so the best answer would be group 15. Choices, groups 1, 11 are way over there. Group 18 doesn't have any metalloids, so it has to be group 15. So group 15 is choice 3. Number 9. Number 9, now you have a little tricky. Which list of elements contains a metal, a metalloid, and a non-metal? So which one consists of one metal, one metalloid, and one non-metal? Doesn't have to be in that order though. And if you look at choice 3, you have Cd, which is a metal to the left of the staircase. You have Sb, which is a metalloid, one of your 6 metalloids. And you have I, which is a non-metal to the right of the staircase. So the best answer is choice 3. Cd, metal, Sb, metalloid, I, non-metal. And number 10, which group 14 element is a metalloid? Group 14, go down to group 14, the only metalloids are sits and gets, silicon and germanium. And the one that's there is silicon, choice 2. Alright, so this concludes our video for today. Click on the next video for, we're going to do pages 9 through 14, I believe. Just checked on that. The last video will consist of pages, 9 to 14. So after you complete this video, the final video will be pages 9 to 14. So tune back tomorrow for pages 9 to 14.